When we generalise, we move from specific instances to statements about categories of things. For example, if I notice that each individual koala I've ever seen is grey, I could generalise to the statement that all koalas are grey. This is an argument. I could write it like this. Premise 1, I've seen lots of koalas and they've been grey. Conclusion, all koalas are grey. Or, in more detail, this koala is grey, this koala is also grey, this koala is also grey, this koala is also grey. You get the idea. Conclusion, all koalas are grey. Now, straight away, you probably wondered how many koalas I need to see to make the claim all koalas are grey. If I was working deductively, I'd need to say all of them. The guarantee that deductive reasoning offers is offset by the huge cost of getting all the required information. It seems we can get by with less than all cases to draw likely conclusions. And it's usually the case that we generalise from just a sample to the whole population. That's what polls do. They take a sample of people, ask them specific questions, then generalise the result. So, if 20% of the sample say they like chocolate-covered oysters, then the result is generalised to claim that 20% of the whole population like chocolate-covered oysters. This is called proportional generalisation. But back to koalas. Think about the conclusion that all koalas are grey. What could I change about my generalisation to make the argument stronger? Two things that will make a generalisation stronger are increasing the sample size and increasing the variety in the sample. Increasing the sample size seems intuitive. The more grey koalas we see, the more confident we can be that all koalas are grey. Increasing the variety in the sample is not so obvious, but let's consider what that could mean. The variety between koalas could include differences in ages, sex, geographical location, or time of year. If we saw koalas across a variety of these parameters and they all remained grey, then we would become more confident that all koalas are grey. Many arguments depend on generalizations. Whenever you hear someone make a claim that is supposedly true in all cases, they are using generalization. Consider these claims, for example.
Pit bulls are a dangerous breed of dog.
Remember, everything is hard before it's easy.
Politicians cannot be trusted.
Philosophers are lovely people, and you have to admit, not bad looking either.
People with hats are terrible drivers.
Bush turkeys are not aerodynamic creatures.
Each of these is a generalization. Someone, or several someones, have decided based on their experience that that claim is always true. Consider now the two ways of testing a generalization: sample size and variety. These two things give us the tools with which we can analyse a generalization to find out if it gives us a conclusion that is likely to be true. We need to be careful that we are generalising well if we want our claims to be believed. There are some problems that can arise if we generalise poorly. In particular, two problems are apparent. They are called fallacies of reasoning because they introduce error into our thinking. The fallacy of hasty generalisation when the sample size is too small. If I meet two philosophers who are extremely clever, I could generalise that all philosophers were extremely clever. That would be a very hasty generalisation, which doesn't mean it's not true, of course. The fallacy of unrepresentative sampling, or biased sampling. If I went to a soccer match and asked people what their favourite game was, it would not be surprising that the answer was soccer. We also have to be careful not to just include instances of something agreeing with our pre-existing definition. For example, if I claim that all philosophers are clever, you might point out an instance of a philosopher who is not particularly clever. In order to squirm out of that problem, I might redefine philosopher to exclude your example, perhaps by saying, oh well, that person does a particular type of philosophy that I don't think is proper philosophy. We should also think about whether the property we are generalising is an appropriate one. If I claim that all philosophers are good looking, I ignore the fact that being good-looking is not logically linked to being a philosopher, making it a poor property to generalise. All these can help us to understand whether a generalisation is a good one, or one we should be wary of. Of course, the killer blow to a generalisation is to produce a counterexample. This is an instance of the generalisation being refuted. For example, if I say that all koalas are grey, then one single brown koala shows my generalisation to be false. Generalizations are what we call universal claims. That is, they can start all things or no things. All crows are black. No politicians are honest. Look for these in daily language and see if you can identify the generalisation and if it's a good one or not.
Oh, yuck!
What's wrong with the coffee?
It's too sweet. This is the second time this has happened. You know, they are always making it too sweet at the university coffee shops.
Fallacy of hasty generalisation. The sample size is too small to generalise from.